Welcome, folks, to a Form 2 mathematics lesson. This is gradient and equation of a straight line. So briefly, what are we looking at? When we dissect the heading, if we chop the heading into pieces, we get three bigger aspects. One, gradient, then equation, then straight lines. So let me begin with straight lines. Straight lines are lines that you know. I cannot simplify further than that. They are lines that do not have curve. It is from one point to another. So that is the thing that is the basis of our study. All of us have encountered straight lines in one way or the other. A straight line has specific name. That is the core of this lesson. Mathematically, we say equation of a line. In layman's language, I can say specific name of a line. I am Robert. You are Jane. Another one is there, Monica. Another one's there, John, and so on. We have specific names. Lines too have specific names. The names of lines mathematically are known as equations of lines. Those lines have gradient, but in layman's language, we can simplify it to slopes. So when I combine those ideas, I come up with each line has its own name and it has its own steepness. Lines have names and have steepness. So we can say steepness is a property of a line. Okay? Let us look at Cartesian plane. I have three lines, L1, L2, L3. Okay? Right. If I asked you which line is steepest, you will definitely answer line L1. Which one is steep? It will be L3. And steeper is L2. Okay? So when we talk of steepness, in layman's language, we are able to see the inclination. The inclination. Okay? The inclination. This, the way it is inclined to horizontal. This. See? That's a different case. That's a different case. That's another different case. Which one is it easier to climb? This? Is it easier to climb? And if you think it is easier compared to this, compared to this. If there was a hill you are going up, which one is it easier to climb? The ease with which you climb depends on your energy. But suppose this energy is constant, then this one poses a higher challenge compared to this and compared to that. Why? the steepness is what is a challenge. So let us look at gradient from quantified point of view. What do I mean? When we talk of this is steep, this is steeper, this is steepest, we want to attach values. So mathematics comes with a format of getting a value, in bracket, a figure, so that you can say this figure is small compared to this, and this one is small compared to that. So when we see figures, we can compare them and come up with the conclusion that this is the biggest figure I'm seeing, followed by this, followed by this. And those figures are the same we describe in layman's language: steepest, steeper, and steep. There will be figures which will tell you this is steepest, this is steeper, this is steep. So in a nutshell, gradient, which we call slope or steepness of a line, must be quantified, must be given a value. Okay? So that value is obtained using specific calculation. So let us just get something here. Gradient in calculation. Gradient in calculation. Gradient using calculation. How do we come up with a figure? I've given you example. Line 1, if I move, line 1 is this. So I've moved one step on the x-axis and I've moved up by 6 steps. Line 2, there are 5 steps, right? 5 steps up. Okay? Line 3, 6 steps right, 2 steps up. So I've tabulated for you this. Now we want to get a specific way of figuring out, of seeing the numbers which will tell us this line is steepest, this line is steeper, and this one is just steep. We are trying to come up with a formula. Using that formula, we shall get figures. Then that figure will tell us the conclusion we have made up. Which conclusion? L1 is steepest, L2 is steeper, L3 is steep. So we want figures attached to those lines. What do you do? From this table, I want you to calculate for me y divided by x. Y divided by x. Y divided by x. During your free time, you do x divided by y. But for me, I want you to do y divided by x. You will do x divided by y. Then the figures you get, see if they can tell us the conclusion we have made. Okay? So let us go on here. Y, for this case, L1 is 6 divided by 1. That is y divided by x. 5 divided by 5, and here 2 divided by 6. We get here third, we get here 1, we get here 6. So from these three figures, can we talk of biggest, bigger, big? Is it possible? biggest, bigger, big. Yes. Biggest, bigger, big. So we can conclude it is matching steepest, steeper, steep. Okay. So can we focus our camera slightly down so that we move on? There. You see? So we can also say this is steepest. This is steeper. This is steep. I am now relating the figures I have found with the conclusion we had made. We should be able to quantify, to get what is the name, the quantity standing for steepness, their figure, because you can draw millions and millions of lines. Okay? So this takes me here. Okay? So line 1, I want to use this point here. That point is O, 0, 0. And I use here, I write there, let me write, this is L1 here, but let me call it point P, this is point Q, and this is point R. So that I have here point P, which is 1, 6. Okay. Okay. So what have I done here? I'm giving you another way. What have I done here? I've done y over x. So this is x1, y1. This is x2, y2. So gradient denoted by letter M will equal to 6 y2 minus y1 divided by x2 minus x1. So what does it become? 6 minus 0 over 1 minus 0, which is equal to 6 over 1, which is equal to 6. So what I want is you to relate these blue figures and what I'm getting here. They are the same. Okay? That is line L1. Let us try line L3. Line L3 starts from O. What is the coordinate of origin? It is 0, 0. This is a letter, but this is a figure. They resemble. That's why I put this in blue points. These are points. Okay? The point there at the end is R. What is the coordinate of R? 6, 1. No, 6, 2. There. D. Okay? So blue is a point. R is a point. This and that are coordinates of O and R respectively. So in black, coordinates. So in each case, I have x1, y1. Then this is x2, y2. But you can reverse. You can say this is x1, x2, y2. And then you take this one as x1, y1. So the ones can be this side or this side. The fact remains, if the ones are here, then this become the twos, the x2, y2. If I pick this to be x1 and y1, automatically this one becomes x2 and y2. So there is no problem there. So can we move down a bit and do gradient? So what am I saying? How can you get gradient of a given line? Gradient of a given line requires 2 points. So if I know 2 points, I can get gradient of a line. How do you do it? You do y2 minus y1 over x2 minus x1. Subtract the y's first in the numerator, then the x's in the denominator. And you cannot reverse that order, that x's come to numerator, y's go to the denominator. No, because we are trying to use what came from the table. You see? So what do we do here now? We say 2, this is y, y2, this is x2, and so on. So 2 minus 0 over 6 minus 0, we get 2 over 3, which is 2 over 6, which is a third. Now, you can see what we had, 2 over 3, just by seeing the movements we had from the table. Now, we are coming to the same thing. What have I added here? The additional thing here is, if I'm given 2 points, I should be able to get the difference of y's over the difference of x's. Okay? And therefore, in conclusion, what do we say now? We say gradient. Gradient is equal to change in y over change in x. Okay, that is our conclusion now. That is our conclusion. Change in y over change in x. Change is basically a difference. So there is something minus something. And when you have negative numbers, you take care, because there will be something different there. So what do I mean now? Here, in conclusion, if we can focus back, gradient, you can now conclude. Gradient is what we have done. In the heading, we shall eventually do naming of a line. Name given to a specific line. So what am I saying? That if you want to get gradient of a given line, you do change in y over change in x, and not change in x over change in y. Not that one. It is specific. Okay? Change in y in the numerator over change in x in the denominator. That is how we get the quantity representing the slope. That's how you get a figure representing slope or steepness. And in the right language in mathematics, we call it gradient, denoted by letter M. So, and it is small m, not capital M. So, folks, can you get, you have known the definition, can you get to the second aspect of this lesson? How can I get gradient when I've been given 2 points? Not all points, not all lines will start from the origin. No. Okay? You can get a line not necessarily from the origin. You can get such a line. And I say this is A and this is B. So if am I to find the gradient of this line, I have to know what is point A, the coordinates of point A. I write them A, then put the coordinates. Then I get also point B. What are the coordinates? I put them in the bracket. Then you can say y of B minus y of A. You see, I started B minus A. So even x will be x of B minus x of A. Do not reverse the orders I have given. They are the ones which determine the size of a slope. Please subscribe, give other students, and then comment. One of you said there is a lesson that the board was not clear. We are very sorry because of the lighting system. Sometimes there is no electricity. I only rely on the sun. Please, I only rely on the sun. If the sun is bright, you get good stuff. If there is no enough brightness, it will affect. But specify that lesson so that we may give you more on that, the application, but not to repeat that, okay? So specify this lesson, the figures were not seen or the sound was not clear. Subscribe, you get more. Bye-bye.